Hey everybody, Tyler here once again to talk to you about spreadsheets, because what else would I be talking about on a Tuesday afternoon? Today I wanted to talk to you about a newer spreadsheet that I made since my last video. Specifically, this one plays Tetris. I had a couple of days off last week and I decided to try it out just based on some ideas that people had. I just wanted to see if I could do it, and the answer is kind of. A lot of you watching this video have probably already played around with it. Just in case, I'll put a link in the video description so you can try it for yourself. You can see I've been playing a little bit here on the screen. I can kind of show you what that looks like. It has 3 buttons that you can interact with. You've got left, down, and right. Because I made it using only built-in Google Sheets formulas, it doesn't do what you're used to in Tetris, where the piece moves on its own. That's because for this challenge, I wanted to see if I could do Tetris using only the built-in functions. That means no Google Apps script, no external code, nothing embedded. And sorry, I'm actually going to turn my own volume down. Playing music here in a video for the first time, so that's fun. So I wanted to dive into the specifics of this spreadsheet because in my last video, I thought that might be too boring, so I kind of just jumped around to a lot of the general stuff. But for all the feedback that I've gotten, people seem to be pretty interested, so hopefully this is interesting to you. Before I do that, I want to talk briefly about why I do this, because this, I realize, is kind of a weird hobby to have. I'm really interested in taking tools that are meant for productivity or general quote-unquote usefulness and seeing how they can be bent and shaped into things that are meant for fun and play. So a lot of my work has to do with taking tools like Google Sheets and making them do things that they really aren't supposed to do, just to see what can happen. The other thing that happens as I do that is I tend to learn more about those tools, because if I'm trying to make something do something that it's not supposed to do, I'll learn weird tricks that I might not have found otherwise. And there's a few of these that I'll get into in the Tetris build. So for me, it scratches that same itch as like solving a really complex Sudoku or building Lego without the instructions. It's a sort of simultaneous play and learning. And that's what this was. And that's why I don't use things like Google Apps Script, is I'm really trying to see what can I do with just this, by comparison, fairly small set of tools and formulas, and see how complex I can make them. So I'll show a little bit of this in action. I've been playing a little bit, like I said, but if you hit right, the piece will move right. There we go, it moves, and it will move down as well. That's kind of my compensation for not having automatic movement. If I don't want to move left or right, I can hit down, and it'll move down. And if I want it to move left, it'll move left. And then as it comes to a stop, it will freeze, and the next piece will appear. Oh, actually, this is a line. Let's see if I can show this off. I played around a little bit trying to see if I could get a line clear earlier, and I actually couldn't do it, and I'll get to why later. I don't have piece rotation yet in this version, so that makes Tetris actually much harder. So see there at the bottom, I've completed a line, and when that happens, the line goes away, and my score goes up by 1. Pretty happy with that. All right, so that's the general outline. That was the challenge, right? To make something that looks like Tetris using only the built-in formulas. I want to show you some of the specifics so that I can show you some of the challenges I ran into and how I overcame them. To do that, there's a filter here. I'm going to allow it to show everything. And now we can see there's actually a lot happening behind the scenes before you get to sort of the display board. The first thing I ran into was I needed to figure out how to show the pieces and how to move the pieces down. Because when you program Tetris using, say, JavaScript, the main way to do it is you would say, all right, this piece is an object, and every turn, every frame, I'm going to check, is the space below me free? If so, adjust my Y coordinate, for example, by 1. Well, the trick with that is that Google Sheets calculates in the opposite direction from the way that Tetris wants to move. Tetris pieces want to move from top to bottom, and that's the same way that Google Sheets calculates. So if I want to see like, oh, is there a free space below me? I can't really know that because that row hasn't calculated yet. It'll start with this row, figure out what that row's set to, and then do that row and figure out what that row's set to, and so on. So it became really unreliable to see, does this piece have space to move down? So the solution I came up with here is each of these spaces is actually calculated independently of the others. Well, not independently, but separately from the others. And so I have 3 boxes here telling me what can happen in that space. And then this monstrosity here is giving me a number representation of what is currently happening in that space. So you can kind of tell here all the 9s are these black squares, these sort of set in stone squares. The 0s are blank spaces, like these. And then the 1s are an active piece. And then in these boxes down here, I then check each of those squares and the squares surrounding to tell the display board again what can happen next. So for example, this box down here we go, is just looking at all of the squares to see, is there a piece that I'm trying to move, and can that piece move down in the board? And how it does that, here, I think this is a better way of showing it. How it does that is actually this board is upside down. It starts at the bottom of the board and works its way up so that each row, each cell that I calculate can be certain of what comes, quote unquote, below it. So here we have a square. So you have 4 pieces that are set to 1. That's my active piece. And here, each of these are just checking to see, is this a 1 or a 3, which I'll get to later, and is the piece above it, which is actually below it, not a 9? And if it is, say true. And if we have 4 trues in that board, that means that the piece can successfully move downwards. And that helps us calculate things like the S or the Z pieces in Tetris, where you may have, well, actually here, let me get rid of this square, and this will be a good example. With just a square, it's pretty easy to figure out that collision, right? You can just say like, are the 2 pieces below me free? And then if so, cool. What about this piece? These 3 are in a different column than this 1. So if let's do this. If I go here, technically, there's nothing stopping these 3 pieces from continuing to move down, but I don't want them to. I want them to be a coherent piece. So what this check allows me to do, let's see if I really should have put some conditional formatting on this. There's true, and then this would be the false. So here we have 3, yes, technically this piece can still move down, and 1, oop, wait a second, there's something blocking me from moving down. So overall, this piece cannot continue to move down. Hope that makes sense. And then I do an additional check to make sure that the player isn't moving left or right, which I'll cover here in a second. And then if everything's good, then it stops and we move on to the next turn. If everything is free, each of these cells, I know this formula up here is kind of a mess, but basically what it's doing is it's saying, if I'm a 0, check to see what's above me. If there's a 1 above me, make me a 1. And then if I'm a 1, check to see if there's a 1 below me and make me a 0. So you're effectively creating the illusion of piece moving by swapping ones and zeros on the board based on the rules of Tetris. Left and right was the next thing that I had to tackle because I wanted the piece to be able to obviously move left and right. Left was fairly easy because I'm doing the same calculation that I do for moving down. I have it check, am I a filled cell? Or rather, am I an empty cell? If so, is the cell to my right filled? If it is, say I'm a 1 now and not a 0. And then if I'm filled and the piece next to me is filled, that means that I just moved to the left, so make me a 0. So what's happening now is actually these pieces are swapping whether they're active. So if I hit left, that saw that this was filled, so it became filled. And then this saw immediately after, because remember we're calculating top to bottom, left to right. The next thing that happened was this saw that this just got filled in, so then this became empty. It sounds complicated. It's actually fairly easy. And I think I can point out the part of the formula that is here. So basically I'm saying if left, which is a combination of have I clicked the left button and can I move left, which I'll show you here in a second. If I'm a 1 or a 3, or rather, if the cell to the right of me is a 1 or a 3, make me a 1. If the cell to the left of me is a 1, make a 0. Easy peasy. And the way that I check if I can move left is the same as the way that I check if I can move right. I have all of these things here that are just saying, is this space a 1? Is this space to the left of it a 0? If all 4 spaces are true, all 4 active spaces, I should say, are true, and you can see them right there, then yes, I can move left. Moving right, on the other hand, is a little bit more difficult, and I'm pretty proud of the way this worked out. Remember, we can only calculate top to bottom, left to right. So it's doing this thing where it's going through each row, left to right, left to right, left to right. While I could pretty easily figure out left, if I say to the cell, all right, I've clicked right, now look to the cell to your right. If it's empty, make yourself empty. And then if you're empty, look to the cell to your left. If it's filled, fill yourself, right? Like that should be fairly straightforward. But because we're calculating each cell in sequential order, by the time I get to this cell, there's nothing in this cell anymore. It's already said to itself, oh, I'm moving right, so I shouldn't be active anymore. I should be a blank space. So what you end up with is you either have a scenario where you hit right and then just the whole row fills in, which looks pretty silly, or you hit right and your piece just disappears because everything goes, oh, I shouldn't exist anymore, bye. So what I did is I actually added in another couple of numbers. I added in 2 and 3, and I can show this in action, I think. If I uncheck left, it's going to move down, and I check right, so it moves to the right, so we can prove that I'd figured this out successfully. What it's doing, and again, here I just have a thing saying, can I move right, where it's checking each piece, making sure there's a free space next to it. Here we go. So I still have a 1 because there's one piece that could figure itself out, but I have these 2s and 3s here. And what that does is it lets me handle the movement to the right while keeping the sequential processing of the cells. So what's happened is, first I calculate this cell and it says, all right, there's nothing to my left and I need to move right, which means I need to be a 2. And the reason a 2 doesn't show up here is just conditional formatting. There's a 2 there, I promise. I've completely whited it out. Then the next cell says, all right, is there a 2 to the left of me? If so, I'm a 3. And I'll get to why in a second. Same thing's happening here. That's a 2, that's a 3. Same thing's happening here. That's a 2. Well, technically that's a 1. I think, right? Let me check. Yes, that is a 1. because what I'm doing is it's also checking, is the thing to the left of me a 2? And am I already a 1? Am I already an active space? If so, leave me as a 1. Totally fine. And then this is saying, all right, I'm moving right. That's a 1 and not a 3, which means there must have been 2 spaces here. So make me a 3, which again, I'm just displaying as the same color as 1s, just for visual parity. So even though these aren't the same numbers anymore, they still appear as a coherent piece. And as I uncheck the right button, the next check that it makes is every cell looks at itself and says, am I a 2 or a 3? If so, I better figure that out and change everything back to 1s so that all my collision can make sense. So the very next update, it changes back to 1 based on what it was before. So all of that to show what we're doing behind the scenes can often look really different from what's displayed to the user, which I find actually pretty cool. And that's a pretty powerful part of conditional formatting, because we can hide a lot of our sins that way if everything just looks the same color. So once I figured out movement, up, or not up, we can't go up in Tetris, down, left, and right, I needed to figure out how to move on to the next turn. I'd already figured out, okay, can I tell the spreadsheet that I can't move down anymore? Turns out, yes, I can. I calculate when they hit the bottom, and I think actually it'll do that now. Yep. Okay, so technically I hit the bottom when I checked the box, and then when I unchecked it, that's another move. That's another update because I've changed something in the spreadsheet. So it's been 2, and then if I do right, it's actually been 0 because I moved right and there's nothing below me again. And this helps emulate that thing in Tetris where, you know, you hit the point that you want to hit, but you need to slide to the left or right a little bit. And it actually won't stop the piece. It won't say, okay, your turn is over until, I think it's when it hits 3. I scrolled down a little bit there, sorry. Oh, well, let's do it again. Yeah, 3 and done. Okay. So what happens is when I hit 3, this value, which is checking to see, okay, can I move left? Can I move right? Can I move down? These are all just named data, by the way, named cells. Or named ranges, pardon me. Really recommend using named ranges. You can see I have a bunch of these here that just help me keep track of like what a cell is for. So when that hits 3, none of these things are true. It says, all right, your turn is over, you're done. When that is set to true, all of these cells check themselves again, and they look for end turn. There we go. If an end turn happens, and I'm a 1 or a 3, so again, any of the active pieces, including if I've just moved right, make myself a 9. And that updates this board so that the once active piece is now a static piece that can't be moved. Then, to get our next piece, and this is another reason that I wanted to have it all separate cells calculating separately, these cells come into play, and they say, all right, if it's an end turn, then we need to figure out our next piece. To do that, we're going to look at, let's see, I have the piece names here. Where's the next piece value? Oh, have I lost it? This is fun. Well, let's find it here in our name. This is another reason named ranges L6. There we go. Oh, there it is. So our next piece, all I'm really doing here is grabbing from a random list. Each of the pieces in Tetris have a different letter name based on their shape. So all I've done is I just have a value where if I don't equal anything, and if it's the end of the turn, just get me a random different piece. And then if this is set to end turn or the reset button that I added in, just set this equal to the next piece, and then we can like keep getting random pieces. So at the end of the turn, these cells look to see what actually not next piece, what current piece is, because that'll update automatically to match what we see here. And then based on the shape, it's just an OR function. So OR current piece. So if the current piece is any of these shapes, I know that this now needs to become a new active cell. It needs to become a 1. And then the whole thing starts over again because each cell is checking, hey, am I a 1 or am I next to a 1? If so, can I move down? Am I trying to move left? Am I trying to move right? Move accordingly. And it all just kind of keeps going and going and going ad infinitum. Do I want to reset here? Yeah, so I'm going to reset real quick. I really like adding a reset button to anything that I make in Google Sheets now. And that's basically like the first thing that I do is I add a checkbox and I make it a named range called reset, because now I have built into all the cells, hey, if this is checked, just set me back to 0 and let's start over. Let's see if I can make something happen here. The next thing I needed to figure out was like, all right, well, I have Tetris now. I have the pieces. I have the movement. I need to figure out, can I actually play? Can I clear lines? Can I build up my score? And to do that, once I'd figured out the collision aspect, the solution I landed on ended up being fairly simple, but it took a while to get to because I kept doing that thing where I wanted the solution to be more complex than it needed to be. And what's happening in the background, this isn't going to happen. I was hoping I could be fancy and show you a row clear, but I showed you earlier in the video. What's happening in the background is that in each of these rows, I have this formula counting how many 9s appear. And because I know that the board is 10 by 20 squares, I can say, all right, if this row has 10 9s in it, set me to true. And then in each cell, I look back at that and see, hey, is this set to true? If so, just make me the row above. And to cascade, so say you get like a true Tetris, right? Say you get a line block that clears 4 lines. The other thing that all of these are looking for is, are there 8 or 10 9s, or is the row above me true? So that way, if I get, say, something here, and I have a bunch of static blocks here, all of these will set to true as well, and they'll all do in sequential order that thing where they say, all right, set me to the row above, set me to the row above, set me to the row above. It's another reason that we have this board upside down, is because if we did it the right way up, everything would be backwards. Nothing would work. The sort of weird thing about Tetris that I'm learning is that very little of it is on the surface. At least, I mean, when you're doing it in a spreadsheet, everything is this weird background stuff that I just stared at for days and finally realized, oh, actually, it's a very simple solution. Just set it to the next row. Just take a row and set it to the next one. For scoring, I do something kind of similar. I have these formulas that are doing basically the same thing. The only difference is that these are not looking at each other, whereas these are. I could probably do this differently, but this is just how I landed on it. And then here I have this counting all of these cells where it equals true. So if a line is cleared all the way up with 9s, or is filled with 9s, I know that that's going to be a line clear, and then that's going to be one more point towards my score. And then every update, every time I hit a button, this frame, or the cell rather, is just adding that cell to itself. So most of the time it's going to be 0, so nothing happens, but then on an update where, say, there's 1 true or 4 trues, it'll add that number to the score. Man, I wish I'd prepared. Oh well, it's fine. Go play, and you'll see what happens as you clear a line. The one thing that, like I said, I haven't gotten yet is piece rotation, and it turns out that makes Tetris actually pretty hard. So I'm not going to be able to get a line clear here for you quickly. The next thing that I had to figure out was, all right, that's how you win. How do you lose? Typically, you lose Tetris by clearing, this is an easier one to look at, clearing all the way up to the top, right? If you reach the top, you're donezo. The trick with that here, and I'll explain how I could have done it. The trick with that here is that I needed these cells to be able to still create pieces before calculating whether or not you've lost. And the reason for that is, again, because we're going top to bottom, left to right. Say a piece lands and it becomes static, then the end turn would trigger, and then these would want to create a new piece. So they would create a new piece, and then it wouldn't be until we go back around to check, is there a 9 somewhere in this top row? And if so, we've lost. So what you end up with is this state where you've simultaneously lost, and you, the player, like, understand that, but the spreadsheet hasn't quite caught up to it because it's still calculating stuff way down here. It needs to get all the way back up here and go back through and go, oh, wait, okay, shoot, we shouldn't have made that last piece. We lost. Okay. So what I did to kind of make up for that is I have this line here, which is another fairly common thing that we'll see in like Tetris-like games. So basically, if you reach that line, then it can still create a piece and look fine, and it will recognize, you have reached this line, and all that is this function here just checks this row to see, hey, is there a 9 here anywhere? If so, we've lost, trigger the end state. But it doesn't look strange if if the board hasn't quite caught up yet. So let's see actually if I can simulate that. It's going to be a lot of clicking here. All of this, like the way it looks, I'm pretty happy with. I do wish that I could have done different colors for pieces, but the way that I'm calculating it with each cell being a number didn't really jive with that because I wanted things to be like very simple to look at. I could do it again and just use a different color for each, or different number rather for each color. And that would be easy enough to do with conditional formatting. I could just go in here and say, all right, cool. If text is exactly, let's say if I wanted an orange color, I could assign that to 7, right? And I could just say like, all right, well, all the L-shaped pieces or all the J-shaped pieces are 7s instead of 1s. And you could do that, but I'd have to go and rewrite everything. And that's just one of those things where like, I like it one color. It's fine one color. I'm not gonna bother. But here we go. So now as I trigger the end state, what you'll see is a new piece will be created. Yeah, see right there. See, it looks really weird. And if I wanted it to go all the top, it would just be even weirder. But now as I uncheck, now it goes, oh, you've lost. Let's turn everything red. The way it does the red is it actually changes zeros to Z's and everything else to an X. And that's just another like sort of final formula here where it says, all right, if game over, which is a thing that I calculate here, and that's just looking at this one that I pointed out earlier, where it's like, okay, is there a 9 here? If so, we're done. So all of these are saying, if it's game over, if I'm a 9, make me an X. If I'm an X, make me an X, because otherwise you run into some weird things. If not, make me a Z. So we change it to just other characters so that I can update my conditional formatting, because again, conditional formatting covers a lot of sins, and now we can sort of signpost to the user, this was not a bug. I know that the game is over, but I still created a piece. It's fine. here's why. Here's what you can do about it. And that's another reason that I wanted the reset button in there, is it makes it really easy to be like, all right, okay, we're done. Let's hit reset. Cool. On to the next. So I hope some of that was useful. Really, a lot of the things that I've learned here have been figuring out how do I get around the way that Google Sheets wants to calculate things, that top to bottom, left to right sort of rule. And a lot about conditional formatting, figuring out, all right, I have this weird thing to look at and it's upside down. How can I make it look like this? It turns out it's just by giving a cell a reference back to the originals in reverse order and then using conditional formatting. The things that I still haven't quite figured out that I may or may not come back to are rotation. Like I've mentioned a couple of times, it's really nice to be able to rotate pieces so that, say, like this J piece could go, so it's selecting like these cells instead. I think I know how I would do it, and I'm pretty sure it would look similar to like these here, where we're checking each cell and the cells around it to see if the piece would still fit. The trick there is that I would have to write a separate formula for each piece shape. So I would check, say, like in this case, right? I would say, okay, for this square, I would need it to look at what shape am I? Oh, I'm a J. Okay, so if I'm a J, I need to look at, is that piece free? Is that cell free? Is this cell free? Is this cell free? If so, then yes, I can rotate. But that would change for T shape, where I would need to check, all right, is this one free, this one free, this one free, this one free? And then I would also need to make sure, okay, do I need to keep track of what rotation I'm in? Because if it's already in that rotation, I need to do a different check to see if those are free instead. And it just gets fairly complicated. I'm sure there's a way to do it that I'm just like not seeing, but it's one of those, I'm going to save it for a rainy day, want to have some coffee and nothing better to do, and then maybe I'll get around to it. The other thing that I haven't done is, and part of this is because I'm not doing it with like Google Apps scripts or anything, so you have to manually move the piece down. But the other thing is the Insta drop mechanic. If you've played a lot of Tetris, you'll know this. You can hit a button in most Tetris games and the piece will just go straight to the bottom. Here you have to click a bunch of times and it's kind of annoying. This is another one of those that I can kind of see where I would go with it, and it would be an extension of the should this piece move down box. And basically what I would do is have each cell calculate how far down it can go, or whoops, no, these are upside down, so how far up it can go. So I would say, all right, for this cell, count the number of falses before a true, or the number of zeros before, here, let's do this. See, this is why I haven't done it. So for this here, right, so this is a 1, so I would have a formula say, if 1, count all of the zeros before the first 9, and then return that number. And then if you hit the down button, you would have to, this is where it gets really weird, you would have to then have the cell that is that number away from this cell make itself a 1. Actually, probably it would be a 3 or a 2, because it'd be similar to moving right. And then make these zeros. So you would do that sort of illusion of movement again, but it would be this like very strange find replace thing that I don't have the caffeine or patience to deal with right now. So I'm leaving it as is, and I am happy. Yeah, I'm looking at my notes now just to see if there's anything I've left out, and I don't think there is. Obviously, this is not a perfect Tetris game. That was never the goal. The goal was to see, could I make something that was Tetris adjacent using only the built-in Google Sheets formulas? And the answer is yeah, kind of. I hope watching this has helped a little bit. Maybe it's inspired you to make some other weird stuff in Google Sheets. It doesn't even have to be Google Sheets, honestly. Like I said, any productivity tool, anything that's like meant for one specific purpose, just see if you can find a way to make it do something else. That could be, as I'm looking around the room now for obvious things, that could be, you know, crocheting something funny. That could be finding uses for those old headphone splitters you have lying around. That could be, it could be Google Sheets too. I've written some stuff. You can go check out my writing at zapier.com/blog, where I work, or my personal website, sandwich.computer, where I write less, but that's where I write the fun stuff that I do on the side. If you have any questions, you can find me on Twitter at CompySando. I've got a link to that in the description as well. Yeah, I hope you have a great day.